All right, guys, we're looking at the day 5-6 self-assessment here. In this case, you are now working with areas of the same four shapes that you had just found the perimeter of in days 3-4 self-assessment. All right, so we are preparing you guys to find the area of your block letters. And the next portfolio assignment that you guys will be receiving, you guys are going to be finding the area of your block letter that's divided up into various shapes. All right. So just a little bit of practice with kind of a funky looking triangle here. Some of you may be looking at this like, well, I want AB to be my base. You can do that. You can. It's going to be a little bit more work because if AB is going to be your base, then your height is going to have to be dropped down from the altitude C. Okay. And if you drop that guy down there to create a 90 degree with the base AB, you're going to have to do some Pythagorean theorem to find out the length of this height. You would have to make sure that the line was perpendicular with the base AB. So yes, it can be done. It'd be a lot of extra work when you can just actually take what's given. BC is flush here, okay, with like the axes, with the grid. So you can just count these, right? It's seven units. So I would go with probably the shortest route here. So you have a base of 7. You're able to drop a height down from A to the base BC. And if it helps, turning your paper or turning the computer so you can actually see this, and so that you can actually see BC as the base and your altitude from A down to somewhere on the base BC, that gives you a height of 6. Okay. Now we're going area is equal to the base times the height divided by 2. All right, so we're going to go base 7 times height 6 divided by 2. So it looks like we're going to end up having, just make sure you guys can still see this, 21 square units for the area of our triangle. All right, the next shape in quadrant 2 is the trapezoid. Okay, now some of you guys see this as a couple of triangles, okay, and a rectangle in the middle, which you can do. You can find the area of this triangle, add it onto the area of this triangle, and then add it onto the rectangle. Okay, but there is a formula that allows you to just find the area of just the entire thing. Okay, so again, the definition of a trapezoid here is it has one set of parallel sides. And you can check the slopes here of these two bases. And these two bases are going to be parallel. Okay, on the graph, they have slopes of 0. So with exactly one pair of parallel sides, you can use the formula. Area is equal to 1/2 of base 1 plus base 2 times the height. Kind of looks like the triangle formula, right? Except instead of just base times height, you got to add the two bases because in this case, we have two bases. Okay. So the two bases will always be the two parallel sides. So we have base 1 and base 2. It doesn't matter which one you label base 1 and base 2. Okay, but base 1 and base 2 are going to be substituted in here. Once again, your height always has to be 90 degrees with one of your bases. Okay, so this guy dropped down to the base DE. This is 90 degrees. So we can designate that as our height. Now, when we substitute, we're going to have the area is equal to 1/2 of base 1 plus base 2 times the height of 4. Okay, make sure you guys can continue to see this. So we're going to have 1/2. It really just becomes PEMDAS, right? Just making sure that your order of operations are all good. So 2 plus 6 is 8. 1/2 of 8 is 4. Okay, and 4 times 4 gives you 16 square units for the area of your trapezoid. Okay, once again, you could have found the area of this little triangle, the area of this rectangle, and the area of this little triangle. Add those three up, and it would also give you 16 square units. Okay, you have those options. All right, down in quadrant 3, we have a circle, or in my case, the one I drew resembles a circle somewhat. So we have circle H here. It has a radius of 2, okay, which means it has a diameter of 4. For those of you that like to use the circumference formula that includes the diameter. Okay, but here we go. The area is pi times the radius squared. Okay, so this just simply becomes pi times the radius 2 squared. And if we leave this in terms of pi, 2 squared is 4. 4 times pi is just 4 pi. Now, if your teacher asks you to round it to the nearest tenth or hundredths, multiply 4 by the pi button, okay, in your calculator. And we'll just leave it as this for now, 4 pi square units, okay? In terms of pi, that's the most exact answer that we can give, okay? Because pi never ends, if you multiply it by pi, that becomes an approximation. So 4 pi is the most exact answer that we can get here. Okay, now the circumference is equal to 2 pi times the radius, or pi times diameter, whatever you prefer. Okay, we're going to go 2 pi, once again, times the radius 2. So the circumference is equal to 4 pi units. Okay, units, not square units, because it's a length, it's a distance. Okay, 4 pi units. Different than 4 pi square units. Merely a coincidence here. Okay, this will not always happen. Okay, our last guy here, this is known as a parallelogram. Okay, now you guys were asked to look up the definition of a parallelogram. The definition of a parallelogram is a quadrilateral that has opposite sides that are parallel. Okay, so technically a rectangle is a parallelogram, a square is a parallelogram, but this is not a rectangle or a square, right? This is not a rectangle. Why? Because the angles are not 90 degrees here. So this is just classified as a parallelogram. Opposite sides are parallel. Now, if opposite sides are parallel, opposite sides will also be congruent or equal distance or equal length. Okay, so if you counted here, this base is 6, this is also 6. This length, I'm not sure what that is right off the top of my head. You'd have to do some Pythagorean theorem here to be able to find it. It doesn't matter. You already did that to find the perimeter, and actually it's irrelevant to finding the area. Okay, so the area formula for a parallelogram is just base times height. That's it. Just like a rectangle. Okay, base times height. Now again, whatever you designate as your base, you have to have a height that is 90 degrees to that base. So if you choose LK as your base from J, you're going to have to drop down a height and create 90 degrees with your base. If you designate IJ as your base, you need to drop down a height that is 90 degrees with that base. Okay, so I'm going to use this height of 4, and I'm going to use this base of 6, and that just simply gives us 24 square units for our area. And that's it. Good job, guys.